Hi everyone. In this video we are going to discuss about electromeric effect. Electromeric effect is a temporary effect and it is also known as E effect, and this is happening in a molecule because of the attacking reagent. So when an attacking reagent we are adding to a substrate or a molecule, so there will be a complete transfer of shared pair of electrons. Basically our compound should be a multiple bonded compound, so there will be transfer of shared pair of pi electrons in the molecule to one of the bonded atom in the same molecule because of the added attacking reagent. So that is basically our electromeric effect. So we'll coming to different types of electromeric effect existing, like plus C effect or positive electromeric effect and negative electromeric effect are the two kinds of effect existing. So now I'll show how this electromeric effect can be represented. According to the definition what I mentioned earlier, so if we are having, I'll write here, if we are having a double bonded compound and I'm adding a polar reagent to it. So according to the definition what I told is, because of the demand of this polar reagent there will be shift of pi electron density to any of the bonded atom. So here because of the polar reagent there will be shift of this double bond to one of the carbon atom. So you can represent the shift of double bond like this. So bonds are basically electrons. When an electron is moving towards one direction or to one atom, so these atoms, carbon atoms, will ultimately have a positive and negative charge. So this carbon atom is losing its electron, so this will be having a positive charge, and this, when I'm putting the arrow to this direction, head is towards this point. So this carbon atom will be having 2 electrons. So the direction of electromeric shift will be in the direction which favors the preferred reaction. So if this reagent is added to this compound, the direction of the reaction will be decided by the polar reagent. And another point which we have to give our attention is, in the case if now we defined electromeric effect in a place where we are having 2 atoms which are of same electronegativities. If one atom is highly electronegative, then what will happen? Then the whole scenario will be changing. In the case where one atom involved in the double bond or triple bond, here we are considering double bond case, if it is more electronegative than the other, so the electromeric shift occurs towards most electronegative atom. So if I am considering a C double bond O, if this is there, as we all know oxygen is more electronegative, so this bond will be shifted towards this direction in the presence of a polar reagent. So the oxygen will be having an electron, a negative charge, and a carbon will be having a positive charge. Now we have to focus on the types of electromeric effect. The main characteristics of the electromeric effect can be studied, like we'll be making a separate video for that. The direction of electromeric shift is determined by the electronegativity of this oxygen atom in the case of this carbonyl group. So moving on to the positive electromeric effect or plus E effect. So moving on to this topic, we should know what is an electrophile and a nucleophile. So for this positive electromeric effect, we should know what is an electrophile. In simple terms, we can say electrophile is a substance. So from the name itself, it is very obvious that electro means negative charge and phile means loving. Phile means loving. That is the term exact meaning of these words. So electrophile is substance which are fond of negative charge or which allows the negative charge. So basically electrophile is a substance or something which have a positive charge. If it is having a positive charge, then it obviously have the tendency to attract a negative charge. So these are basically positively charged species which will be attracted towards a negative charge species. So here we should need a attacking reagent for mentioning our electromeric effect. So when an attacking reagent is an electrophile, that means the one which will be having the tendency to go towards highly electronegative center, the electromeric transfer of pi electrons will be taking place towards the attacking reagent. So that is called basically positive electromeric effect. So I'll explain with an example. So consider this example. In this case, there is no electronegativity difference or anything. So this is just a carbon double bonded carbon compound. And if I'm adding an electrophile means negative charge loving. So it will be having a positive charge. So if the electromeric shift of the pi electrons of a multiple bond is towards an atom to which the reagent is getting attached, it's called positive electromeric effect, as I told. So here, as usually in the attack, because of the demand of the polar reagent, shift of the bond will be taking place. So here this is the polar reagent and shift also took place to this carbon. So what will happen is this kind of charged species will be produced. So I'm drawing that kind of charged species again. This will be having positive charge and this will be this compound. So now what is positive electromeric effect is, if this charged species is going to attack on the carbon or on the atom where the electrons have come across, or when here in this case electrons are moving towards this carbon, and if to the same carbon if this electrophile is attaching, that is positive electromeric effect. So in this case here towards this carbon the bond will be coming or electrons are shifted, and to the same carbon if the electrophile is coming, it is called positive electromeric effect. So onto this, when our electrophile is coming, here positive charge will be there. This is what is happening. Here our Y will be attacking. So this is a product of our plus E effect. So like this, I'll give an example for the same thing. Positive plus E effect plus E effect example. I am taking an ethane molecule. To this ethane molecule, I am adding a proton. So what is happening? So we have to shift one bond. When we are shifting this bond, here a negative charge will be coming and here a positive charge will be coming. According to plus E effect, the electrophile should attack the place where there is negative charge. So this should attack here. So our product according to plus E effect will be, this is the, let it be the new proton attached, and here you will be having the positive charge. So you will be getting an ethyl cation out of ethene molecule. So this is basically our plus E effect. If you know plus E effect, it is very easy to understand the minus E effect. Here in the case of plus E effect, let me repeat once again, the positively charged species or the electrophile, it will be attaching the place where the electrons got shifted or where there is negative charge. So coming on to minus E effect, when the attacking reagent is a nucleophile coming into picture, that means a nucleophile is coming into picture. Nucleophile means nucleus loving. Nucleo means positive charge, we have to assume like that, and phile means loving. So something which loves the positive charge. So a nucleophile itself have a charge of that means itself have a negative charge. So when the attacking reagent is a nucleophile, that means which seeks an electron deficient center or a positive center for its attack, the electromeric transfer of pi electrons takes place away from the attacking reagent. That is called our minus E effect. Let me explain by an example. So in this case, the same example I am considering, you have this kind of entity and electromeric shift is taking place. And here your polar reagent according to the definition will be something which have a negative charge. A negative charge species, that means nucleophile, that is positive loving species. So you will be having, let it be said, which is having a minus charge. I am just taking a random example. So when this is getting attached, for minus E effect, our nucleophile should attach this carbon which is having a positive charge, or we can say this electromeric shift of pi electrons takes place away from the attacking reagent. This electromeric shift should be towards another end and the attack should be in one end. So according to minus E effect, the product will be, after the shift of electrons, you will be having a negative charge here because this bond is getting shifted to this carbon. So you will be having a negative charge over the second carbon, or over the first carbon you will be having a positive charge. Nucleophile will be coming towards this direction. So you will be having a Z attached in this position. So this will be the minus E effect product. So in the same way, if I am considering a polar reagent like the carbonyl group, C double bond O is there. So we know oxygen is more electronegative than carbon. So oxygen will be taking electrons towards the carbon direction. So this bond will be getting shifted to this direction. So it's obvious that here a positive charge and here a negative charge will be coming. So our nucleophile is a negatively charged species, or nucleophile means positive charge loving species. So this will be coming and attaching in this place. So your product will be, here you will be having the Z. So this is all about our minus E effect. And one more thing which you have to keep in mind is, one way of representing the electromeric shift which will be operating during the nucleophile attack of cyanide or Cn minus ion, which is generated from HCN. You know, Cn minus is generated from HCN. So that is something which is very different. So I'll draw that condition here. So HCN, and you are having an OH minus. So what will, it's not an equilibrium. So what will happen is, here you will be having a Cn minus plus H2O. And from this Cn minus is the nucleophile, and this will be attacking, not the OH minus will be attacking. In this case, the H, in the case of HCN, so there are chances that you might get wrong, like with the OH minus ion and the Cn minus ion. Not the OH minus ion, Cn minus ion is going to attack. So I'll draw a simple reaction here. So if you're having this molecule and this Cn minus is coming. So what will happen is, oxygen is more electronegative, so bond will be getting shifted in this direction. So, and this Cn, this negative charge will be attacking this carbon, because you will be having a positive charge over this carbon after the shift of electrons or this bond towards this oxygen, more electronegative oxygen. So what will happen is you will be getting a tetrahedral intermediate where oxygen will be having a negative charge, and here the CH3 and here the hydrogen. So you will be, and here our Cn also, this will be a tetrahedral intermediate, and then our H plus ion will be attacking. So H plus ion will be attacking, so you will be getting a CH3, COH, H and Cn. That means an acetaldehyde cyanohydrin is formed. So the electromeric shift of the pi electrons of the double bond of a carbonyl group is away from the carbon to which cyanide nucleophile is getting attached. And this is an example for minus E effect, and it's very important example you have to keep in mind always. Thank you.